Going global. It's one of those terms that we associate with great success and amazing tech and large-scale companies. With cloud computing, however, it doesn't have to be that way. Your application can, with relatively little effort and cost, also serve a global market or even partly global. I'm Lars Klint, Azure Training Architect with A Cloud Guru, and in this project, I'll show you how to take a website, any website, and you can make it both robust and globally available. Here, let me show you what we are going to do in this ACG project.
Throughout this project, I'm going to use slides to teach some of the theory around the services that we're using to building this global app. There won't be many, but there will be some. Now, first of all, we are getting hold of a website. I have created one on GitHub that you can use if you want, or you can bring your own. BYO websites, it's a thing. Once we have the website up and running, I will show you how to connect GitHub to Azure DevOps to set up continuous integration, and then we configure an app service to receive the website code and host it on Azure so it can be on the internet. Having a website on Azure doesn't make it global though, so let's fix that with using Cosmos DB to get the data closer to the user, and Azure Front Door to get the website closer as well. Don't worry if all of this doesn't make sense just yet. I'll explain it all in details throughout the project. And as with almost any software and cloud project, this is not the only way to do this. This is a way, not the way. What will you need then to follow along with me? A few things that are all free. Yay! An active Azure subscription, a free tier is fine. A DevOps account, you can use the same credentials as for Azure. An IDE that can compile .NET 5, such as Visual Studio or Visual Studio Code. And well, that's it. I won't go through how to install any of these and set them up in this video, but you can pause now and do it. Pause it. Yep, go. All right, ready? Let's get into it.
In this project, I am not going to show you how to build a website for two reasons. Well, three. One, there are a ton of different ways of creating a website, and this isn't a project to figure all of them out. Two, this project is about making apps global, not creating the actual apps themselves. And three, I've already prepared one that you can use as well. Also, we start creating our build pipeline, which is the preferred way of building, testing, and pushing most web applications to production. We will use Azure DevOps for this task.
Let's start with GitHub. Acquired by Microsoft in 2018, this is a website that can securely store your code, version it, and manage access to it. The name GitHub comes from the views of the version control system Git, which is integral to the service. It's a very popular service and has over 100 million code repositories on the site, which is a lot. They have over time created more products such as GitHub Pages, a blogging and documentation platform, GitHub Actions, a code building and deployment tool, as well as several smaller features. You can set up a free account, which is enough for any open source project. If you want to use their services commercially, you have to cough up some dollars though. So what are the benefits of using a service like GitHub? There are many, most of them doing stuff humans are not very good at. Source control of your code means you have a central place your code calls home. This is backed up and doesn't get lost in the drawer of broken dreams. Versioning. You can go back in time and deploy code that isn't broken or find out why a particular decision was made. And collaboration. When everyone have the same code base to work on, you can manage the deployment process much easier. GitHub and similar platforms won't stop people from making mistakes and writing bugs, but it makes it both much easier to fix quickly and to learn what went wrong. Alright, let me show you GitHub in action. We are now here in GitHub and we are looking at the repository for this particular project, this ACG project. And this is the app that you can use for this project, or you can bring your own as well. You may have to adjust what you do slightly if you bring your own. Now there are different ways that you can get the code from here into Visual Studio or whatever IDE, integrated development environment, that you're using. I can show you two ways here that we can start with. And one is you go to code here and you can simply open it with Visual Studio. This will then ask if you're okay with this opening it in Visual Studio, and I'll say, yep, sure, that's fine with me. And then Visual Studio is going to open. So this is obviously the repository location. That's where we are now. It will ask me where I want to put it on my local machine. And that is as good as a location as any, so that's fine. And I can then click clone. Now clone means that I take the code that is online on github.com and I put it on my local computer, but I keep the connection between the two. I have essentially a copy of the code that knows about the online repository, which means that I can push changes and change requests and pull requests up to github.com. So click clone. There we go. That'll then clone the repository. And here is Visual Studio. It's now going to load that solution locally. So it's copied all the files to my local computer. And now it's going to open those files or this solution in Visual Studio. So I'm going to go down here to Solution Explorer. And we can now see here are all the files in this particular solution. So that is probably the easiest way to do it. It also means that you keep the connection for github.com. The other way that that you can do it, that I want to show you, is that in github.com you can go into the code again, and you can simply download a zip file. Or if you're a bit more advanced, you can get the URL for this particular repository and you can clone it yourself using either the tools in Visual Studio or another Git tool that you prefer. So those are the ways you can get the code onto your machine. So let's just have a look at what the application does. So I'm going to click on the play button here, run it in IIS Express with Chrome. And that's going to start up a Chrome instance, Chrome browser instance for me to show what that particular application looks like. And here we are. So this is the application. Very simple, very straightforward. You can enter a bunch of values here, whatever you prefer. There we go. And I've just made up some values here. These don't actually mean anything. The aim of this project is not to teach you how to write a web application, but simply to have one that we can then use here. There we go. We're going to upload dancing last screen. Now, none of this data is going to go anywhere, and I'll show you. So if you click submit, it's simply going to show you, here's the return values for what's been uploaded. And if you look at the code, back at Visual Studio, I'll just stop that and I go in and I look at, if you're familiar, this is an ASP.NET Core MVC.NET 5 app, bit of a mouthful, but that's what it is. If I look at the controller here, and we have a home controller, all this does is it gets the model back. This is C# code. And I create a new key and I store this particular model as a JSON string. I serialize it into JSON and then I just store it in the session. That's all that's happening. Now we are going to change that a little bit later on to get into Cosmos, but for now, this is all it does. So we've just cloned this application and now we can run it locally and now we know where it is in GitHub. And then we can go on and we can look at the next part of this project. It isn't enough to have the code living somewhere. You want to use that code to create an application or service of some sort. You want some way of moving your code to the server where it will run. One such tool is Azure DevOps, which is also typical Microsoft naming. The tool does lots more than DevOps, and it works with many more platforms than just Azure. Thanks, Microsoft. Anyway, DevOps consists of 5 different tools within it. Boards for managers to keep track of the project and its tasks. There's a lovely burn down chart, which they will love. Repos, which can hold your code, just like GitHub. Pipelines to create code deployment procedures and automate the tediousness of code transfer to production. Test plans to create manual and automated tests for your application. And artifacts, which is a kind of built-in NuGet package manager for your team. In this project, I will only focus on the pipelines to move our website from GitHub to Azure. And you might be thinking, well, why don't we use Azure repos to host the code? And there's no reason we can't. I wanted to use GitHub though for 2 reasons. Number 1, Azure DevOps works with lots of tools outside the 5 that I mentioned before. There are thousands of integrations with third-party services. Using GitHub gives us some insight into how this works. And number 2, GitHub is the most widely used code management tool, and it is important you know what it is and how it works. So let's create our first Azure DevOps pipeline then. So this is Azure DevOps. This is the first screen you'll see when you log into a brand new Azure DevOps account. And the first thing we need to do is obviously to create a project for our ACG project. So we give it a name, ACG Project. Very, very original, I know. And you can give it a description if you feel like it. This will be the build pipeline for our ACG project. And, well, dance moves. Well, because why not? So once you've given it a name and a description, you can then choose whether you want a public or private project or repository. And public means that anyone can see it. Private obviously means that you have to log in, you have to give access. So we're going to choose private. Then you have to choose your version control. Most of the time you will be using Git, I would argue, but you can also choose Team Foundation Server. So create your project, and when that goes through the motions, it goes pretty quick. And now we have access to all the parts of Azure DevOps. Now we're only going to focus on pipelines in this project, but you can also go and investigate boards and repos and test plans and artifacts if you feel like it. So click on pipelines, and this will take us to the new pipeline screen, because obviously we don't have any pipelines yet. So we are going to create a new pipeline. A pipeline is a way to automate your build process and deployment. So click on create pipeline. Now we need to define where our code is. Now we know it's on GitHub because we've just seen that we put the code or the repository on GitHub for our project, but it could also be inside of Azure DevOps, Git Azure repos Git, or it could be another Git client that you might use in your company or for your project. The next step is that we then need to select the actual repo, but of course we need to authenticate with GitHub to log in. So I'm going to do that through my GitHub account, which is where the code is for this project. If you're using the same project as me, you may have to fork that into your own GitHub repo to get access to it through Azure DevOps. Then we authorize the pipelines to access that code. And here we choose the top one, which is the one that I've just created. So ACG Project Global. And then it analyzes the code that's in the repo to kind of give you an idea of what it could be, what template you might want to use for your YAML code. Now in this case, it's ASP.NET Core, because we know that. It's .NET 5. And then it configures it, and we get a YAML template. Let's have a look at the YAML. At the top, there's a pool. That's the VM image that we're going to build this project on, or this solution. There's some variables of which solution to build, which platform, etc. Then we have the steps, which are the steps that it's going to perform for us on that VM. So we have first our restore, and get the code. Then there's the build, and then there's the test. So those three have been created for us, which is quite neat. Now we're going to add one later on to put the code up for deployment to Azure. But for now, this is enough. And we can pretty much just take it as is. It's nice that they have these templates, but do spend some time on understanding the YAML, I would recommend. And here we can then save and run this YAML template. Give it a commit message. Always give it a commit message. And then when we are ready, we just click save and run. And well, you don't have to run the pipeline if you don't want to, but it's kind of neat. It shows you, or it gives you a confidence that your code is actually working. So let's just skip through the build here. First it queues it, and then when it's been built, then it comes back and it says either success or failure. So that's the way that you set up a build pipeline. We can click on the job here, get a bit more information about what's actually involved. So here's all the steps. We have a initialize jobs, then we check out the code. We go through the NuGet tool installer to get all the right tooling to build it on that virtual machine. There's an enormous amount of logs, as you can see. If I scroll down to the bottom here, it's just massive amounts of logs. Now they can come in handy when you're debugging, so don't discount the verbosity of these logs. Then you have the build step and the test step. So now our build has been put into a pipeline. We have continuous integration. You get that for free. So that means that every time we check in code to this repository on GitHub, it will build it on Azure DevOps, and we will always have an idea of whether it's succeeded or failed. And it'll also run the tests as we add tests, etc. and all that. So if I go back into the YAML here, This is where we can then add tasks. You can see on the right-hand side, there are some predefined tasks that we can just use that will insert like a template kind of YAML for you. And you can then, adjust as you go. But YAML is the way to go. This is what every single automation tool will be using. So it is very well worth learning more about YAML. But there we go.
So far, so good. Code is flowing from GitHub into DevOps. It's being built and tested. Our code is happy, but it has no home still. That's where Azure App Services come in. In this part, I'm going to get into the Azure world and find our code a home. We're making the code run. And when the code runs on Azure, you have to configure the application as well. And you need to handle development versus production configurations. More on all that to come. Before we start creating some Azure resources, let me clarify app services and app service plans.
Let's start with clearing up a basic point of confusion that I come across all the time. The difference between app service and app service plan. Despite the terrible naming, knowing the difference is critical to using app services. Now, in a nutshell, the app service plan is the virtual machine that runs, your app service. Or, app services, I should say, plural. Which immediately brings me to possibly the lowest hanging fruit on the app service fruit tree. You can have multiple app services on a single app service plan. In fact, you should whenever possible. All right, let me explain. When you spin up an app service plan, you pay a monthly fee for that. And it doesn't matter if you run 1, 2, 8, or more app services in it. It is always the same price. I've seen companies that have had a single app service plan for each app service, usually because of management reasons or some other excuse. Now, this meant the companies were paying many times more than they had to. Once you have your app service up and running, the main thing to keep track of is development versus production environments. If done incorrectly, it can cause a real mess and many, many headaches. The way to do this is to have distinct configuration files and setups for each environment, all the way back from the source code. I'll show you what that means in just a second. So we're back in the Azure portal, and now our application needs to live somewhere in Azure, and that is an app service. So we can go here on the left-hand menu, and we can go down to app services. That is one way to get to them. There's always multiple ways to do things in Azure. Go into the app services menu, and we're going to create a brand new shiny Azure app service. So click on create app service. And then we are presented with a wizard. Like most other services on Azure, there is a very nice wizard to sort of guide you through what they need to know. So the first thing is we need to choose a subscription. I already have my ACG Training Architect subscription here. We need to create a new resource group because I like to keep projects in resource groups. So this one's going to be called ACG Project. It makes it easier to manage all the resources that are in a particular project. We need to give it a name, so obviously ACG Project, because that's very inventive. We'll just do a quick check. Yes, that is a domain that is available. All app service names need to be unique. We're choosing .NET 5 as the runtime stack, because we know it's a .NET 5 app that we're creating. The region, I'll leave it at Central US. You can choose whatever region you'd like. And now we need to choose the size of the app service plan. The default that's chosen is usually a reasonably average app service plan. Now, the app service plan, as we saw before in the slides, is the actual VM that everything is running on. So we can choose this P1 V2, or we can choose a different app service plan, a different, basically VM that you want to run this on. Now, bear in mind, you can run multiple things on these VMs. You're not restricted to a single app service. You can also run functions and all sorts of other things. We have a dev test area or family of app service plans. There's one that's free, but it does not run very much or very often. And as you choose the various levels here, you can see that you have more and more included features in hardware. So here's the shared infrastructure, which means that you share the actual VM with others. You're still sandboxed, so you won't have any contamination from other apps, but you will share the resources. Or we can have basically the lowest app service plan is the B1. And that is what we're going to choose for this particular project. You can choose another one if you feel like it. You can choose an existing one as well. If you have one that you're already using, there is no need to create a new one in that case. So here's all our settings. We're then going to go to the next step, which is deployment. Now this is a preview step. We're not going to use deployment from Azure. We're actually going to use it from DevOps, as you'll see soon. So we're not going to enable this, but you can also push code via Azure rather than via Azure DevOps. We choose if we want any monitoring. I will always recommend having application insights on your app services. It just makes debugging and error management so much easier. And you don't know you need it until you really need it. So skip past tags. It does a quick validation of the choices that we've made, and usually they're fine. And then we just simply click create on this particular app service. And then through the magic of editing, you don't have to wait very long for this to be created. Now it takes a couple of minutes usually. As you'll see here, it goes through the deployment process and then cue the elevator music, and then it is done. Well, now it's done. Your deployment is complete. So go to that resource and we'll have a look at the app service that we have created called ACG Project. Now there's a way I want to show you AIM templates, because this is one of the key parts of using Azure efficiently is automating things. I mean, that's why we're going to look at Azure DevOps as well, building pipelines. Now in here, in the Azure portal, you can get the AIM template, so Azure Resource Manager template for this particular app service. So you go down here to automation and then export template, and it'll show you the template as it is that creates this particular app service. So this is actually what is being run through the Azure Resource Manager, is this exact template to create the service that we've just looking at now. So you can use this, you can download it, as I'll show in a second, and you can manipulate it and change the values to what you need it to do, and you can check it into source control, and actually you can version it, you can automate it, you can run it over and over and over again and create more and more resources, or tear them down and build them up again if you have a test environment. It's very, very powerful, and it's something that you need to know about. Now, we're not going to use AIM templates too much in this particular project, but now you know where they are. You can download it for the one that you just created, have a look through it, get an idea of how it works. It's just a zip file, and it's just a JSON template. That's all it is. So you can open it, have a look at it, and it looks exactly like we just saw in the portal here. So AIM templates, learn about them, use them. They are golden. All right, we'll go back up to the overview here. So now we have an app service. That means we have a live website, and it has a URL. It has a web address, which is given here on the overview, called acgproject.azurewebsites.net. So we can go to that, and obviously we haven't deployed anything to it. So there's just a placeholder default project now being hosted, which looks like this. Every single app service will look like this until you deploy your code to it. But it works. This is now live on the internet. So whatever name you've given your app service will now be live as well, and you can go to it and have a look. Now, I just want to mention, as I said before about deployment, you can use the deployment center in Azure, and you can choose the source that it comes from. So, for example, from Git. So we could bypass, in this case, Azure DevOps completely. I don't recommend doing that, because you lose all of the goodness that is in Azure DevOps, all the testing, all the third-party integrations, all of the other tooling that does come with Azure DevOps. You lose that, but you can do it in Azure. So, but we're not going to do that. Next, we're going to connect our app service to Azure DevOps. And to do that, we need to have a connection, an authenticated and secure connection. So I'm going to go into here to Azure Active Directory. I'm going to create what's called an application. So this is basically a user, but like a headless user. So there's no actual user name and password for this particular user. So I can use this to go into Azure DevOps and create a connection. Now I have one called ACG Project here. I now have to go to the subscription that I am part of, so the ACG Last Client subscription, and I have to give that that application in Azure Active Directory access to the subscription. Now this will all make sense in a second, but I'm going to add a role assignment of contributor to this particular user, or this particular service principal, as it really is, called ACG Project. So I choose that as a role assignment. I then give it the role of contributor, which means that this particular user or service principal can now access the resources in this subscription. And obviously I need that for Azure DevOps to be able to push code to the app service we've just created. So this is maybe a bit tricky. This is important to get right these steps if you are using a service principal, which most of the time you would be using. Now I'm just going to leave it here on those settings because I need those in a second. Go back to Azure DevOps, and we're now going to create a release of our code. So you can see here, I'm going to add some extra YAML. This is the publish to the artifact. The task is called publish build artifacts $1, and that's the task name, and it has a path to publish, which is a variable, and then an artifact name and a publish location. Container just means that it stays within DevOps. I'm not going to push it to an external file service or anything like that. Now we save this, give it a good commit message so that others know what you've been doing. Save it. And now our build process has an extra step, which means that it builds it and it then pushes it to the artifact repository so that our release, which we're now building, can grab that artifact and push it up to Azure. Now the release pipeline is obviously, releasing, we're going to deploy this to Azure. So it's an Azure App Service deployment. You can apply that as a template. Very neat. And all we have to do now is we have to add an artifact. That's the one we've just put in with the YAML, that extra bit of code. And we can then choose it here as lclient, etc., whatever it is. Now this is going to tell me there isn't a latest version because it's still building. So, but it'll be there by the time that we need it. So that's our artifact. And then we have to choose, where do we push it? This is where the service principal we just created comes in. So now you can see here there are going to be no Azure subscriptions because I haven't put in the service connection yet, which is with the service principal. So do it manually. Automatic is only if you have set it up differently. I need to put in a subscription ID, subscription name, etc. I get that from Azure. That's why I left it on this screen. So I need the client ID, and I'm going to put that into the service principal ID or client ID. I need the tenant ID, and that's also on this screen. You can copy that directly as a directory or tenant ID. And then I need a service principal key. So that's, again, back in the service principal under certificates and secrets. Click new client secret, and then add it, description, and you'll just get a unique key. And that key now authenticates that service connection in Azure DevOps. And this key, you can only copy it now. You can only see it as it's created. Once you leave this screen, you cannot go back and get it again. So make sure you copy it. Then we need the subscription ID and name, and that's just back on the subscriptions. Go to via the search or however you find your subscription in Azure, and that's the subscription ID there, and then the name as well. Not sure why you need to put the name in since you already got the ID, but anyway, extra check. And then we can go and we can verify that this service connection is correct. And this sometimes is a little bit tricky to get right because there's a few values that you need to create and a few connections, especially if you forget to add the managed identity. And then you have to give it a name, ACG Project or whatever. Give it whatever name you think is correct or right. And then you just verify it and save it. And then we have a service connection. Now we can now use that service connection for any of our pipelines. So you only kind of have to do that once for every connection between Azure DevOps and an Azure subscription. So that's kind of neat. And there it is, ACG Project. There's our app service name. Now I just want to show you one more thing under the next step here, deploy Azure App Service. So first of all, we set up the connection. Now we're looking at the actual steps. So there's what we just chosen, the actual app service. Down here, there's the package or folder that we're going to push up. We're not going to change it, but if you had a more complex structure of where you put your files and your folders in Azure DevOps, you can click on the Browse button there next to it, and then it'll actually give you the linked artifact directories, and you can choose another one. Now, we're not going to do that, but it's just nice to know that you can access the file structure within Azure DevOps for this particular bit. We save our release, and we call it just initial version. There we go, and click OK. So now it's saved. So let's just check to make sure that the pipeline is finished. So we have an artifact. Yep, that looks like that's correct. Let's go back to releases, and it's still called new release pipeline. Let's just fix the name on that because that looks a bit silly. give it a good name here. ACG Project deployment. Yeah, that'll do. Save that again. Give it a comment. Name change. Yep. Always give it a comment, I think. That's just good practice. And now we can create a release. So let me just show you a couple of post-deployment conditions here that you can put in. So there's a few different steps that you can add to it, and you can make these deployment pipelines more complex. We're not going to do that here. Just be aware that there are a lot of different settings that you can fiddle with and choose should you so desire. But again, Azure DevOps is a huge tool. We're just going to create a simple pipeline now, and or release pipeline, and that's now going to push our artifact up to Azure. So click on the release link here and we can see it as it goes along. Now I'm going to use some editing magic here and just skip ahead so we don't have to sit and look at this, but it doesn't take too long and it just happens all automatically. So there we go. And it is complete. So now our code has been pushed up to Azure. So let's go and see if it works. Yeah. So go back to Azure, and we're going to go to our app service here, ACG Project. And again, we can see here that the link is still the same, the URL. So we haven't changed any of that. We've just simply pushed code up to it. So let's open it again. Here we go. And there's the website. And there it is, just like we saw before, exact same thing. We can fill in the form just like before, and the code is still only stored in the session. None of that has changed, but it is now on the actual internet. So we pushed our code up, and it's all done through Azure DevOps into Azure App Services. Now, there's a part of this Azure App Service here. There's the configuration, which is really important. This is where the config values for the entire app service live. And this includes your deployment values, your connection strings, your any environment variables, anything that you have of that nature, you can add into here. And that'll overwrite the web config or the app config in your application, in the code. You can have connection strings in here, which will mean that they are secure. They're transmitted over an encrypted channel, as it says right there on the screen. And it's just good practice to have these. Now, these can be automated as well, so you can publish automatically through Azure DevOps. We're not going through that in this project, but you can do that. There's other settings, general settings. We're running .NET 5. You can change, whether you're using WebSockets and keep it live and all that stuff. So the configuration of the app service is actually really important. Often I see people forget about this. They only add a couple of things and then they manage everything through code. Essentially, it's much better to let Azure handle these things for it. And there's, as we can see here in the code, if I go back to the web config, these values here will be passed up to the website, but the rest of it, or if there's any with the same name, they're actually overridden, will be done from Azure. So it's a much better way of handling configuration values if you're using Azure anyway. And then there's one last thing, is that ideally you should never ever just deploy to a live instance of your website. You should use what's called deployment slots. So let me just show you where that is. Here on the left, it says deployment slots. Our app service plan doesn't actually support deployment slots, but we could have chosen a different one that did. But deployment slots are identical copies of your app service, but only one of them is live. They each have their own URL and you can access them, but only one is actually live, and you can swap them instantly, which means you can deploy to one slot that's not live. Once you're happy with it, you can swap it instantly, and it just gives you a much better control of where your code is and when it's going live. So if something doesn't work, it just doesn't go live. So you can have this sort of fail-safe check essentially, and you can have someone else look at it. And you can use deployment slots for a lot of different options as well, such as A/B testing, staging sites, showcase sites, etc. But yeah, just bear in mind, deployment slots are very cool, and they're free. They're included in the app service plan. All right, onwards.
All right, let's talk data. Up until now, our website is running on Azure, but it isn't exactly global. Time to start changing that. One of my absolute favorite services on Azure is Cosmos DB. This globally scalable, sub 10 millisecond latency, horizontally scalable database is a case of Dr. Jekyll and Mr. Hyde, actually. On the one hand, you have what appears to be a standard relational database that you write data to and read data from. On the other hand, It's a mystery of hidden features, multi-language API implementations, and features it'll take you years to discover. Wondering why they called it Cosmos? Well, because it's for managing data at planet scale. Yeah, nerds. Anyway, I love it because it's so simple to use and to use in the way that you like and see fit.
Let's look at the speed and scale of Cosmos. This is often the main selling point before price enters the conversation. You'll often hear single-digit millisecond response times as a selling point. And while that is true, it does come with certain prerequisites, such as services being within the same region and being configured correctly. Now, the really cool part is that it's really easy to set up. Whether you are using the portal or through another interface, a lot of the magic of creating a globally scaled database is hidden from you. And that's a good thing. Now, Cosmos DB has a concept of read and write regions. Read regions is any region you configure as part of your Cosmos DB account. Write regions are specific regions that can also be written to. If you have one write region, then all data is automatically synchronized with the other regions. If you have multiple write regions, well, then magic happens and they all are synchronized as well. Oh, you want to know about scaling? Well, if your Llama rental service suddenly takes off because you finally got John Malkovich to endorse it, then Cosmos has you covered, at least on the data side. As the graph here shows, as demand and traffic grows, Cosmos DB will scale and follow. It is a completely managed service, meaning you don't have to worry about having enough resources or managing any systems. All right, enough talk. Let's see the beast in action. First, let's create a Cosmos DB in Azure. And there's, as always, a number of ways that you can get to the Cosmos DB screen. I'm just going to choose the one that's over at the top, Azure Cosmos DB. So to create your first Cosmos DB, you simply just click the Create Azure Cosmos DB. And this will bring up the familiar wizard for creating resources on Azure. Again, you can also do this through the CLI or through PowerShell, but we are using the portal for this project. We have to choose a subscription. Of course, that's the same. We choose a resource group that we already have, ACG Project. And then we have to give it an account name. And it has to be all lowercase, because that's the way that Cosmos DB works. The API, there's a few different ones. We're going to stick with core SQL. The location, that's fine. The capacity mode, there's a new serverless way you can do things, which you may want to play around with. We're going to choose the traditional provision throughput. And then we're going to use the free tier discount as well, which is very handy. That's a relatively new feature for Cosmos, that you can have a free tier. The networking, we're going to allow connectivity from everywhere because we want to use it locally as well from our desktop. The backup policy, we're going to leave that as is, but you can change that if you need to. We're going to let Azure deal with the data encryption using the service managed key. So Azure is going to manage that key for us. Again, tags, which is on every resource. And then there's just a quick validation check to make sure that we have all the values that we need to create a Cosmos DB. And then when that's finished, we simply click create. And that's it. It will then create a Cosmos DB for us. Go, deployments in progress. And through the magic of editing, it's going to be done in just a minute. There we go. Your deployment is complete. So let's go to the resource and have a look at our new, fresh, shiny Cosmos DB. Go to the resource, and that will open up the overview, and then it would take us to the quick start because there's no data in the Cosmos DB. It'll ask us, hey, how do you want to set up data? How do you want to get data into here? Well, we're going to connect our app. So what we need is actually the keys to connect directly from our application that we built, our web app. And those keys are down here on the keys, and that'll have a URI. So that's the direct link or web address for our Cosmos DB, and some keys that we can then use and connection strings as well. So these will be unique to your instance, of course. So let's go back into Visual Studio. And well, first we just copy the URI, and then in Visual Studio in the app settings, we need that URI as the account. So you paste that into there. So these are the settings for Cosmos DB in our application. So there's the account, and then we need the primary key, which we also just copy, and you can paste that into the setting there for the primary key as well. That's all we need. Now we have all the connection details we need for Cosmos DB. Now I've made a few changes to the project here that I'll just run through. First of all, in startup, There is an add singleton, which is the dependency injection that we use to every time that the system sees iCosmos DB service, like there, it'll give us the following, which is the initialized Cosmos client instance async. And that is an instance that we can use to then connect to Cosmos DB and upload our data from the form on our website. So there's the key, Cosmos DB. That's the key that was in the app settings.json that we just inserted. Down here is the initialize Cosmos client instance async function, and that'll then use that key and get all the different values out based on the app settings.json as we see here. So that's how that works. And now our application knows about Cosmos DB. It knows what values to use to connect. And we can now then go and use Cosmos DB in our application. Now there's a service here called Cosmos DB service, and that has a number of functions: add item async, delete item async, etc. We're only going to use add item async, but you can see that takes a user element, which you pass into it, and then that gets created on Cosmos DB on the database that we just connected to. So that's really neat. And then there's a few more functions here that we're not going to use, but you can use them as reference for your own project if you need to. They are basically copied or referenced from the Microsoft documentation. I have adjusted it slightly to make it work with our application here as well. So hopefully that'll make sense. And then in the home controller, I've now commented out the session storage that we had before, and I've just simply added a reference to add item async and passed the model into it, and that's it. It will then redirect back to the form itself and clear it, and the data will be stored in Cosmos DB. Now remember, this is not about data validation, data sanitization, any of that. This is purely to get some data into Cosmos DB. You would have some checks on this if this was an actual production system, of course. So you don't want people just to insert any kind of data. For our intents and purposes, it's fine. We can insert data into Cosmos DB, and you learn how to connect your app to Cosmos DB and create one as well. So just bear that in mind as you go through this. And you can see the changes in here. Now we've hooked it up to Git, as we did earlier in the project, and you can see the files are now changed, which means you can check them in, and then they'll be built on Azure DevOps. The ID here is worth noting that the ID that you pass on to Cosmos must be lowercase I and D for it to work. So I'm just giving it a GUID, which is a random GUID, and that will work as the ID for the row in Cosmos DB. But that's important, lowercase ID. That's just how Cosmos DB works. I can now run it. And that'll, of course, compile it and build it. And then it'll bring up the local instance of the website, but is now connected to the Cosmos DB live instance. Now, there are ways that you can use a Cosmos DB emulator locally. So you have a local Cosmos DB essentially, but we haven't set that up, but it might be something you want to investigate. Now we can enter some values here. Any kind of values. Again, there's no validation or sanitization around it. It's just that we had different kinds of values that we can insert into Cosmos DB and choose any file there. And then we submit it, and then that will then create the database for us. So if you go and you look at the code, it will use the settings for Cosmos DB that we inserted, and if that doesn't exist, that database in Cosmos DB or that for that Cosmos DB account, it will then create the values for us. So we don't even have to create a database. There we go. It's now been submitted. Again, there's no validation, there's no confirmation, but the form clears. We can then go and look at Cosmos DB. So we go to the Data Explorer. We can then go and investigate or interrogate the data. So under my profiles here, I have user, and then the items are always called items. That's the collection of rows, essentially, of data rows in Cosmos called items. And we can see here, it just loads. And there is the data that we just inserted. And it brings it up as a JSON format. And you can see there's all the values to be inserted. And there's some underscore values as well. These are used by Cosmos to manage the data internally. So there is some, don't delete those. There's some tags there, underscore, whatever. Of course, this project is about going global. So Cosmos DB is a globally scalable database. You do that by going to the menu Replicate Data Globally, which is this. There's a map. You can choose, currently we have East US and West US as our regions for Cosmos DB. They're both read and write. If we want to have another region, all we have to do is click on one of the regions on the map. So if we want to say to have one in, let's say, Europe, we simply go and pick the one we want. West Europe, France, Central. West Europe's good. We click on that. And now it's added to the list. We can then configure multi-region rights, enable or disable. Again, bear in mind, if you enable rights, it is going to be more expensive, but also faster. You get the data writing of your application closer to your user. Now, there's a very nice warning here saying if you want to keep it free, keep your account completely free, stay in one region with 400 RUs, read units, and 5 gig of storage. So now we save this, and that takes just a second, especially with editing, before it's updated. But yes, do bear in mind that Cosmos DB cost can go up, especially if you enable write regions where you don't need them or read regions where you don't need them. So make sure you know where your users are, where they're using your data, your website from, and enable those. Be specific about which regions you enable, and that may be some trial and error, but it is important both in terms of cost, but also in terms of experience for your users. And that's it. Now the Cosmos DB region has been configured and magic just happens. That's all you need to do. There's nothing else to do now. For Cosmos, it still is just the same connection strings and keys and everything. You just write like you normally would, but there are just more regions for you to use and it'll make it faster and more global. Nifty!
So that's the data sorted when it comes to global, but how do you get the site as close to your users as possible? How do you make sure that no matter where your users are geographically, they don't wait too long for your site to load? And you know what I mean, because waiting more than 3 seconds on a website usually means you go somewhere else, right? Now you could deploy the site to multiple regions around the world, but that creates a fair bit of management overhead, and every time you achieve new levels of glory in other regions, you would have to deploy it again. Not going to work. Instead, use the fast, reliable, and secure content delivery network that Azure offers. It's called Azure Front Door.
At its core, a content delivery network, or CDN, is a network of edge nodes, which is another fancy word for servers closer to your users, that has a copy of your website or assets such as images. The net effect is that you get quick transfer of assets needed for loading internet content, including HTML pages, JavaScript files, style sheets, images, and videos. Your users will wait a lot less, and that is good. Azure has a CDN product, but they also have Front Door. Front Door has a CDN feature built in, but it also does global load balancing to route traffic to different regions when needed, super easy integration with services, real-time analytics, and a bunch more. It's like a CDN with a superhero cape. Front Door will make your application feel local no matter where your users are. All right, let's build the last part of our application. To add Azure Front Door to our project, we're back in the Azure portal. And however you find your services, again, sometimes they're up here if they're reasonably used, and you can use that, or you can also search for them. So we can type front. As an example, you get front doors. So we go into front doors and we're going to create. Now, the front door is, as I said just before in the slides, is that this is a service that sort of wraps your website and gives you a bunch of services such as a CDN and further stats and so on. Now, let's create one by clicking the Create Front Door button again. And this time the wizard is going to be slightly different. So first of all, we just have the same kind of choose subscription resource group. We're going to choose our ACG Project resource group again. You'll see here the resource group location, which is where the Azure Front Door is going to be placed as well. So next we go to configuration. Now we have to choose a front-end domain. So we click the little plus, and here a front-end host or front-end domain it's a subdomain of Front Door. Basically, it's a way of routing the traffic via Front Door to our website, which is in the back end. And we'll get to that in a minute. So we're going to give it a host name, so it'll exist on the internet, and we're going to call this ACG Project. Of course, does a little check here, and that's okay. Now there's a couple of options. We can have session affinity, so if it's important that your user in a session uses the same backend machine. Now we're only going to have one backend machine in this case, but you could have multiple. Then you want to enable this. And then there's the web application firewall. We're not using the WAF in this particular project, but if you did have a web application firewall, you could enable that as well there and use your rules on how to manage the traffic through the firewall. So we're going to add that as a front-end host. And then we need to choose a backend pool. Again, click the little plus. And we're going to give it a name. So we all call this ACG Project Backend. And then we need to add a backend. So for each service, we need to add it in here in the backend pool. So the host type, as you can see, we have several. We know we have an app service, so I'm going to choose that, but you could also have cloud services and storage and everything. There are many ways that you can speed up the access to your Azure resources using Front Door, but we are going to use an app service. And of course, we only have the one, which is the ACG project that we created earlier, and then you can choose the ports and the priority and so on. Now the weight down here, as it says, you can assign weight to different backends. So that means that if you have one with a higher weight, it will go to that backend first if it has capacity. So there's a way of you can sort of prioritize where the traffic goes. And it's enabled. So we're going to add that. If we had other backends, if we had another app service that we wanted to use in a different region, for example, we could add that as well. We have health probes. Now we can add a path. And that means where on the backend pool or the app service as it is that the traffic will go to. So in this case, we're going to choose root, but you could also have other services on this app service that were on different paths. So we add that. And load balancing, by the way, sorry, just before we add it, you can add load balancing here based on how many users you want to have or how many sessions you want to use for this particular machine. We add that. And now we need some routing rules. So you add, again, click the plus. We're going to give this a name. So we can call this ACG Project Route. Oops, forgot the G there. We'll make it right. There we go. And we can accept protocols from which front end. So obviously you could have multiple front end if you really wanted to make it complex. And then we need a route detail. So we want to forward it to the ACG Project backend. So this is a way of forwarding traffic to a specific pattern, from a specific pattern to a specific backend pool. And again, as we said before, the backend pools can also go to specific paths on that particular app service or storage or whatever the resource is. We can enable forwarding protocols, URL rewrites, and caching. We're going to leave it all as default for now, and we add that. And then we go next, as always, is tags. If you want to add tags to it, tags are very useful. This is the way that you logically define, for example, which department owns a specific resource instead of using your resource groups, which are more project-based in my opinion. But we're not using tags in this project. Go to the review and create and just make sure that we have filled in everything correctly. And the validation is passed, so click create. There we go, the deployment is now complete. So we can go to our resource, our front door. And here's the overview of the Azure front door resource. Now you can see the front end host, which is the name we gave it before here, acgproject.azurefd.net. What do you think happens when we go to that URL? Let's try. Yep, it's our website. Because now everything goes through front door. So we could assign this a domain, a new domain name. And say it was, acgproject.acloudguru.com, for example, we could then assign that domain as a DNS entry or a custom domain. Our website would go through front door and it would choose the right backend pool, it would choose the right front end, and so on. It's very cool. And we now also have a CDN. So now our website is hosted through Azure Front Door, which means that our website is now on all of the edge nodes, all the Azure edge nodes that are closest to the user. So we essentially have moved our website closer to our users. Now, when they access the website through Front Door and Front Door doesn't have a valid cache or doesn't have a recent cache or there's resources doesn't have it all, then it does need to go back to our website, to our app service. But other than that, everything is cached and is on the edge of the internet, as it's called. It's closer to our users. And that's all we had to do. It's very cool, very neat. There's a bunch of things in here. You can, of course, you can use the Front Door Designer, which is the wizard we went through. You can add more backend pool resources and more routing rules and so on. We can use the WAF, the Web Application Firewall, if you want to set that up. That is a good idea to set up a firewall for this. The Web Application Firewall is slightly different from our virtual machine firewall, of course. And then again, there's the rule engines configurations and the usual automation task. And you can also export the template for this into an ARM template. But that is Azure Front Door, and now our project is global. We have globalized our very basic website, granted, but that's some simple steps that you can use for your next project to make sure that your application is as performant as possible for all your users.
You made it! You've now turned a simple website into a global masterpiece. Well, it's global at least. You've created a deployment pipeline from GitHub via Azure DevOps and into an Azure App Service. Whenever new code is pushed to the GitHub repository, it is automatically built and tested, and this is called continuous integration. We then hooked up Cosmos DB to the app and configured a global database solution in minutes. Finally, Azure Front Door was used to move the website resources closer to our users by using the Azure Edge nodes or servers. Well, that's what nodes are. It was a lot of information to take in this project, but these are some of the ways that you can have a global infrastructure with the power of Azure Cloud Computing. I hope you've enjoyed this ACG project, and if so, give us a thumbs up. Also, please add any comments, questions, or suggestions below, and I will do my best to clarify and help you out. Consider subscribing to the channel for more cloud computing content. Thanks for watching. Vi ses næste gang, and keep being awesome cloud gurus.